So James, I think your role at ESA is really fascinating, and it is such an exciting time, isn't it, for the space sector? And we really are going back to the moon, and I'm so proud that ESA is a part of it. So can you tell us about Europe's role in the Lunar Gateway and all the research opportunities that it's going to bring to us?
Okay, so the Gateway, for anyone who's not familiar with it, is a human-tended platform. It's going to be in an orbit that's near to the moon. It's an international project, so NASA, United States, with Canada, JAXA, and ESA, maybe with Roscosmos. So it's the ISS consortium partnership, but then taking that international partnership and going beyond and as a basis for exploration. And so the Gateway will start being built during the early 2020s. So the first flight is currently planned for 2023. That would launch something called the Power Propulsion Element and the sort of very small habitable volume called the HALO. And so we in ESA are contributing to, we're contributing the service modules for Orion, which is the crewed vehicle that will take astronauts sort of beyond low Earth orbit for the first time in decades. And we're also later on going to be contributing something called IHAB, or the International Habitat, to the Gateway as well. And the Gateway becomes a platform from which we can explore the surface of the moon, but we can also prepare for human missions to go beyond, onwards to Mars. But we also see it as somewhere where we can do research that's unique to deep space. So we're looking at how the deep space environment looks, how that affects human explorers, but also we can do some fundamental research into the physics of that environment. So things that we've been looking at are cosmic dust, heliophysics-based plasma type research that we could do there, and sort of biological type experiments looking at the effects of that integrated environment on biology. So we in ESA are providing one of the first two scientific packages for this mission. So we're providing an integrated radiation package, and that will partner called URSA, and that will partner with an American led package called Hermes. Together they'll look at the integrated space plasma environment there.
In terms of getting to the science part of it, what year do you think all this will be kind of happening? I know it's hard to project exactly, but just around, what are the projections?
Okay, so Gateway, which is not at the surface of the moon, that's something which we'll start building up during the mid-2020s, and then that'll be built up over the rest of the 2020s. Lunar surface activities, so the first human mission is planned by NASA for 2024, and that will have science content attached to it as well. So there's now a science technician team in the US that are starting to plan the science on that first mission. And of course, we in ESA are very interested in becoming involved in the science of that and later Artemis missions, and becoming more and more deeply involved in what happens in human missions at the surface. And for that reason, we're now working on what we call the European Large Logistics Lander. And this would be a European lunar lander, which can carry up to around 1.5 tons of payload to the lunar surface.
Wow.
So it's a big vehicle, launched on Ariane 6-4, and that platform would be able to provide crew on the surface with cargo, scientific equipment, but we could also have self-contained robotic missions deployed by that lander. And the idea is that once you've built this capability, it's not a single mission. It actually doesn't make a lot of sense in terms of the cost of the project to do a single mission. It should be a recurring vehicle that we can use every sort of 2 to 3 years to deliver new missions, both robotic and supporting crewed activities. And with that, we want to get deeply involved in the science opportunities that are being opened up by this.
And do you think that will start in the 2020s, like the late 2020s or the mid 2020s, or?
Well, from the mid 2020s, I think you'll have the human missions at the lunar surface. That's the plan. And the Large Logistics Lander from us, we expect to be ready around 2027 is when we think we can have that ready for. So hopefully we'll have a really substantial European-led scientific activity at the lunar surface from around 2027.
That's really
but in advance of that, like the whole world is trying to get back to the moon, right? So the Chinese, India, Japan, Russia, I mean, everybody's doing it. And so we're also working with international partners to provide earlier scientific contributions to these missions. So a major focus for that is on the lunar poles. So the lunar poles have become the go-to place, the confirmation of this very old idea that you could have water, ice, and other cold trap volatiles in very dark, shaded places. So now that it's there, and so there's really a drive to go and explore these places. That's partly because these volatiles can provide a record of the inner solar system and volatile history in the inner solar system. But they also are a potential resource for future exploration. And so they have both a scientific driver, but there's also an exploration drive to go and explore these places. So we are providing a package called Prospect. Mm-hmm. So Prospect is a package which can drill around 1 meter beneath the surface in the polar regions, extract samples which could contain water, ice, and who knows what else. Transfer these to a chemical laboratory where we can look at the chemical composition and the isotopics of these volatiles, but also perform some experiments to show the viability of different processes for using the resources that we find there. And we're providing that for the Russian Luna 27 mission for 2025. We're also now talking to NASA about providing the same package for a commercial lander mission in around 2024-25, and there's interest from other agencies potentially in flying related packages. And this is really part of an international effort to comprehensively explore these areas for science and also future exploration. So this is very exciting.
You know, it's going to be a really great decade ahead. And thanks very much for just giving us a tiny little taster of what's to come. So thanks a million for joining us today.
Bye.